Hello, Augies Worldwide. I'm Dave Kessler, amateur radio call sign KE0OG, and we're here with another episode of Ask Dave. This question comes from Mike, AC6PC, and Mike is asking about a convention regarding standoff distance of window line with metal. DX Engineering set afoot online research showed that it was 2 to 3 widths of the window line, and when I consulted the ARRL antenna handbook, the transmission line section, it cited a few inches. Can you help me narrow it down, please? Thanks in advance. And 73. It's a trade-off type of a question. Now, if you look at coaxial cable, all of the RF is contained inside the inner shield of the coaxial cable, okay? And if it's good coaxial cable, you don't see anything outside. Such cables like that, you can lay right on top of metal things. You can lay on the ground. They can get wet. They can whatever, okay? Not true of window line, which is 2 parallel lines. So 2 parallel lines would be in 300 ohm twin lead, which is still available, or in 450 ohm ladder line, or in 600 ohm open wire line, which is pretty big. Okay. Now, in those parallel transmission lines, they're balanced lines, meaning that as current flows one way on one, it flows the other way on the other one, and it keeps going like that in an AC fashion at the RF current that you have there. Now, the skin effect is important, sort of, for these, but what's more important is that the radiating fields of the RF in there, there are fields surrounding it. The actual energy travels in an electromagnetic field that's around the antenna. How big is this electromagnetic field? Well, technically, infinite. Goes out to the edge of the galaxy. But, of course, beyond a few inches, it's negligible. Now, the reason we don't like to put ladder line in coils, because the different coils will interact with each other, so you have it kind of spread out on the ground, and even then having it on the ground, you're going to have an effect. If you put it next to a building, like a steel building, then yes, there will be an interaction. The question is, how much interaction? How much can you tolerate? So there is no hard and fast answer. The fields that are surrounding that decay exponentially. And you want about 1/5 of the original fields. And so you can get standoffs in a variety of lengths. I think DX Engineers about 9 inches, so that would be why it's that. For TV, traditionally the length has been on the order of 3 inches. If it's right up against a metal wall, I would do 2 things. I would keep it maybe 6 to 8 inches, maybe a little bit more away from the wall. And as the wire goes up, go ahead and give it a twist. So the wire will be sort of, a long twist on the thing. You've seen that probably in pictures. And the reason for that is because that makes the electromagnetic field do the same, and it can both add to and cancel the part of the interaction that it has with the metal on the wall. So there's no hard and firm answer. I would keep it several inches away, like 6 or 8 if you can. You can make your own spacers, as long as they're non-conductive. You can make little fiberglass things that have got some kind of a plate on it you screw into the wall or so on. But make sure that it is either fiberglass or PVC or something like that. And again, twist the wire as it goes up. So every couple of feet it's got a complete twist. All right, so you may have to lay this thing a little at a time to get the kind of twisting that you want. And now this brings up the question of how do you get it through the wall to your shack? Do you want to put a 1 foot wide hole in your steel? Probably not. Okay, so one way that it's done is with insulators. You get these 2 insulated pieces, and they'll bring the wire through. Will you have an impedance bump there? Yes, you will. So, I don't know. Also, be sure to put a rain loop. If you've got coax or open wire line coming down, don't bring it directly into your building, because water hits that thing, runs down it, and will go right into the building. So you create something called a rain loop, where the thing comes down like this, comes back up an inch or 2, and then goes into the house. And then the water will come down and drain off the bottom and not be a problem in the house. So I hope that helps answer your question, Mike. There is no hard and fast answer. So do what you can to get it out there separated. And, you know, as you run it up to a roof eave, you'll go further away from the metal and so on. Just keep it 6 to 8 inches away. And really, like I said, it's an exponential decay. So every extra inch adds less and less and less isolation. So somewhere in the middle there is 6 to 8 inches. So there you have it. Now, if all of you have been watching this far in the video, I'd like to ask you to make sure that you're subscribed. And if you click on the bell, you'll get notifications of new videos and notifications of our weekly live stream, so that you can come in on that. The live stream is just a nice chat between us Augies, and if someone has a question, I'll try to answer it. And we generally go for a while. Also, be sure to check out the giveaway. We give away something every month. This month, I'm recording this in December. It's a microscope, a nice electronic microscope. Not electron, but electronic microscope. It's very nice. So, until we next meet, 73.